welcome back. We're going to deal with unmanaged types. So let's first succinctly define what an unmanaged type really means. So an unmanaged type is not managed by garbage collection. That's what it means. So in the .NET framework, there are two pieces of memory that are important. There's a heap and a stack. The stack is where unmanaged types get added. And when they go out of scope, they fall off the stack. It's very simple. The heap is where reference types go. And the important part about that is that the garbage collector comes back later, cleans up the memory for those reference types when they fall out of scope and are no longer being used. But that is the exact way that you create memory allocation issues if you don't carefully manage your reference types. The good news is that if you follow some basic practices with managing memory, you're really set up for a path of success. But it is important that you understand the difference between how memory is managed with unmanaged and managed types. So unmanaged types are, in short, this kind of list of value types. Enums, pointer types, which we won't deal with in this video, probably won't deal with in this course. They're exceptionally uncommon. And any user-defined struct that contains fields of unmanaged types only. Okay, so for example, here's some values for some value types. I used some shortcuts here for decimal and float. You see the trailing M and the trailing F here that defines what type they're implied as. 1.5 here without any trailing definition is implied as a double. Okay. So the big key to unmanaged types, well, specifically value types, not necessarily unmanaged types, because it wouldn't be true for structs, for example. But the big deal is that you can get a size of property on the type itself. Okay? And so, for example, a Boolean takes up a certain amount of space. A byte, a short, an int, a double, so on and so forth. Take up a certain amount of space. Well, then when an object is created, that's actually going to be thrown on the heap, not the stack. This is a managed type. Unmanaged, managed. Now here's an unmanaged struct. The reason it's unmanaged is because it only has unmanaged types for members. Okay? But here's a managed struct because it has an unmanaged type for an integer, but then a managed type for a property here as an object. But you're going to notice something interesting as you watch the memory allocated. So let's just kick the application off. And let's come over here and let's take a snapshot. And so this is the amount of memory being used once we hit this read line. And so if we can see the heap size here. We can see how many objects are in memory. If we click on this, we can look at the different types of objects that are in memory, how many of them, and how much they're using, right? How much memory they're using. So let's scroll down, for example, and let's just take a little look. Here's a Boolean. We have one of them. It's taking up 24 bytes. Okay. Here's, let's scroll down a little further. Here's a byte. We have one of them. Takes up 24 bytes. Okay, and it's 16, which is a short. 24 bytes, a double, 24. So on and so forth. 32 for the decimal, right? And if we come over here, the size of here is the size that is defined, right? 1, 1, 2, 4, 8, 16, 4. And so you can see there's a bit of a discrepancy between the size and the actual memory that is allocated. And that's because there's memory allocated for other pieces inside of a short, okay? Inside of a double. Other pieces of the puzzle that help them, produce that type. So this is how memory actually is allocated, how it works. Now, if we run over here and let's just an object was created. So right here, this line executed, an object was created. We can take a snapshot and notice that the number of objects in memory went up and the heap size went up. And that's the important part. The unmanaged types are added to the heap, not the stack. Okay? So we're going to go create an unmanaged struct, and you'll notice that when we do so, nothing actually changes. Okay, because what you're taking a snapshot here of, really, this snapshot that you're talking about here is the heap, because that's what's most important. That's the one that causes you trouble. A managed struct was created. Now, here's something interesting. You're going to notice that there's no difference between the two snapshots. And the reason for that is because this property is currently null. So if we were to set a value to it, though, and pull a snapshot, you'll notice that we have now more memory allocated on the heap. And I wanted to use this as the example for unmanaged types because it can often get conflated with unmanaged code. Not the same thing, okay? So an unmanaged type just means that the garbage collector doesn't manage the memory. That's kind of the bottom line. But these structs were important because if you do build a struct and you're thinking that, hey, I'm saving memory, but it has a reference type on it, you may not be saving as much memory as you think you are. It's not that you shouldn't use a struct. That's not what I'm saying. I'm just saying that when you throw a reference type on here, the whole struct becomes managed at this point. So keep that in mind. Until next time, happy coding.